Hello everyone, my name is Ariana Lopez and I am a Senior Partner Solution Architect with AWS. Today we will start part 1 of a series of videos that will explain how to use a proxy server to connect to a public endpoint for AWS IoT Greengrass version 2. Security is top of mind for industrial companies and many are asking the question, how can I securely connect to a public endpoint when a private endpoint is not an option? And that is what we will be discussing in this video. For our agenda, we will be discussing what is AWS IoT Greengrass, how authentication works for AWS IoT Greengrass, the challenge, the solution, and how to set up the environment. AWS IoT Greengrass is an open source Internet of Things, edge runtime and cloud service that helps you build, deploy, and manage IoT applications in your devices. There are many different use cases for Greengrass, but here are a few. With Greengrass, you can build software that enables your devices to act locally on the data that they generate, run predictions based on machine learning models, filter and aggregate device data, and build edge applications using pre-built software modules called components that will connect your edge device to AWS services. Authentication in Greengrass version 2 is shown here on this slide. If we look to the left, we have an AWS IoT Greengrass device, and that device has an IoT certificate. For Greengrass to authenticate, it has to follow a series of steps. And the first step is that the Greengrass device will make an HTTPS request to the credential provider for a security token. The request will include the device X509 certificate for authentication. In the second step, the credentials provider forwards the request to the AWS IoT Core Authentication and Authorization module to validate the certificate and verify that the device has permission to request the security token. In the third step, if the certificate is valid and has permission to request a security token, the AWS IoT Core Authentication and Authorization module returns success. Otherwise, it sends an exception to the device. In the fourth step, after successfully validating the certificate, the credentials provider invokes the AWS Security Token Service to assume the IAM role that you created for it. AWS STS returns a temporary limited privilege security token to the credentials provider. And in the sixth step, the credentials provider returns the security token to the device. In the seventh step, the device uses the security token to sign an AWS request with AWS Signature version 4. And in the eighth step, the requested service invokes IAM to validate the signature and authorize the request against access policies attached to the IAM role that you created for the credentials provider. And lastly, if IAM validates the signature successfully and authorizes the request is successful. Otherwise, IAM will send an exception. And so this is how authentication works for Greengrass version 2. The challenge is that some customers don't want their resources to interact with AWS resources over the internet and prefer to use private endpoints. However, what happens if a service doesn't have a private endpoint? And that brings us to our solution. If a private endpoint is not available, customers can use a proxy server to restrict what can access the internet. In this proof of concept, we are going to demonstrate how AWS IoT Greengrass can use a proxy server to connect to public AWS endpoints. In this scenario, we will use the public endpoint of AWS IoT Credential Provider as an example. And this is why we went over how Greengrass authenticates with AWS IoT Credential Provider on the previous slide. Please note that as of this recording, AWS has a private endpoint for the AWS IoT Credential Provider, and that we are using the public endpoint, in this case, for demonstration purposes only. Also, in this proof of concept, we are using a single proxy server for testing purposes. We do not recommend using a single proxy server in a production environment. Here is our architecture diagram for this proof of concept. This is what we will be building throughout this video series. If you look to the left, we will build a VPC, also known as Virtual Private Cloud, with public and private subnets. To simulate a device on a manufacturing floor, I will create an Amazon Elastic Compute Cloud instance, also known as EC2, in my private subnet and install Greengrass on it. In my public subnet, I will create an EC2 instance where I will install my proxy. We will also build out virtual private endpoints for the following services: AWS IoT Core, AWS IoT Greengrass, Amazon Simple Storage Service, AWS Systems Manager, and Amazon CloudWatch. And then we will also need to use Amazon Route 53 to build private hosted zones. And then the blue box at the bottom of the diagram is a high-level representation of the authentication and authorization process reflected on the next slide. We went over how Greengrass authenticates already, so I won't review that again. So now let's go build. And so the next thing we want to do is we're going to build. So we're actually going to start building, and what we are going to build is a virtual private cloud, also known as a VPC, as well as subnets, which is going to be our public and private subnets. So let's go ahead and get into the console. So I am in my AWS account, and this is the landing page I landed on. Here you can see I'm at my console home, and where I want to go first is to my VPC. And something else to note is if we look to the upper right, you'll see Ohio, and this is the region I'm going to be building in. So this is also known as US East 2. As you can see, we have other options we can select, but I'm going to build in US East 2. So I'll click off that. And then as you can see, we have this big yellow button called Create VPC. We will click that. And here for our VPC settings, we have VPC only, we have VPC and more. And we are going to actually create VPC and more. So if we look to the right, we'll see that we have VPC, subnets, and route tables, and any network connections that we want to create. And that is what we want. So here under name, tag, and auto generation, we will put in Greengrass V2 POC. I will leave the IPv4 CIDR block as is. I will leave pretty much all this on default. And then what I want to do is ensure my availability zones are correct. So here we have 2 selected. We will leave that alone. And then we're going to move down to the number of subnets that we want. So in this case, we could get away with only having 1, but we'll go ahead and just choose 2. So 2 is selected by default for both public subnets and private. Then we will go down to NAT gateway. And in this instance, we will want a NAT gateway initially when we start to build our infrastructure. And then at the end, once our Greengrass device is up and running, we will then take away the NAT gateway to ensure we have a private connectivity. So we will do in 1AZ. And then for VPC endpoints, for now, we will say none. And then at the bottom, we have DNS options, and both enable DNS host names and enable DNS resolutions are selected, and we will leave that as is. So if you look to the right in the preview, we can see what our VPC would look like. We have Greengrass version 2 POC VPC. We have 4 subnets, 2 of them public, 2 of them private. And then we have our route tables, and then we have our network connections, the internet gateway at the top, and then our NAT gateway at the bottom. All right, so now we click Create VPC, and this will take a couple minutes. So that took about a minute or 2 to complete, but if we scroll all the way up, you'll see success, and we can go back to the bottom, click on the yellow button, View VPC, and you can see our VPC is now ready. This concludes this video, but please join me for our next video where we will create our security groups.